Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
So my talk sort of largely reflects Dave's sentiments to a very large extent, but sort of what I want to talk about is what I think enterprise network management means and entails, and sort of talk about existing tools and what they cannot do as far as network management goes, and the reasons for their inability to do these things. So just to give a very sort of quick primer on where I'm coming from, I've not spent as much time thinking about this topic as some of you in this room have, but whatever little I've looked at, sort of, whatever little literature there is, whatever few white papers there are, it seems like this topic is very broad and covers a lot of issues such as, tuning the performance and availability of servers or, specific links in your network, sniffing traffic, collecting data, analyzing, inferring certain key characteristics, monitoring network utilization, mapping out network topology, mapping out the location of resources, users, and so on for troubleshooting or forensics, etc. And there are several tools, both commercial and free, that sort of provide these management functionalities. And there are tools that are tailored to enterprises of different sizes and different requirements. But instead of talking about existing tools and what they do provide, in this talk I want to talk about what existing tools do not or cannot provide. Specifically, what I want to highlight is that there are specific management functionalities that are highly desirable, that I think are highly desirable for enterprise networks, that existing tools and techniques either find it very hard or it is impossible for existing techniques to support these functionalities. It's fundamentally hard for existing techniques to support these functionalities. And I'm going to try to argue that the inability of existing techniques to support these functionalities arises out of specific facets of the design of enterprise networks today, namely the decentralization of policy configuration and execution, as well as the lack of control over routing. And finally, I'm going to try to abstract out design principles for enterprise networks that, if they adhere to, would make all these management tasks almost trivial. Okay, so what exactly are these management functionalities that I think are important but cannot be provided today? So there are at least three that I can think of that would be very useful to support. The first is the ability to do what-if analysis. The second is the ability to sort of have a live view of what is going on in the network, obtain information about various useful network events at arbitrary granularities and so on. And the third is the ability to achieve fine-grained control over the resources in an enterprise network. Of course, I'm going to explain what I mean by each of these functionalities as we move on. And in each case, I'm going to try to tell you why I think existing tools cannot support these functionalities and the reasons for that. Okay. Now, I may not be bang on right when I say that there are no tools that support one or more of these functions, and feel free to correct me if I'm wrong. But I hope by the end of this talk you'll be convinced that there is no one tool or one set of mechanisms that can effectively support all these functions. So what do I mean by what-if analysis? What I essentially mean is the ability to understand a priori what might happen if I make crucial changes to my network. Let me illustrate by means of an example. Let's say that the system administrator of an enterprise, or say Microsoft, decides to add a specific new network link or a new switch for redundancy purposes, or just a simple network upgrade. The kind of questions the administrator may be interested in answering is, would this impact the existing configuration or the existing policy in my network? For example, could this inadvertently create bypasses to existing policy checks? How will this impact sort of resource consumption in my network? For example, let's say the administrator decided to upgrade configurations on a bunch of middle boxes and routers. Would the resulting configuration be stable? Would it be sound? Would there be inconsistencies? And so on. In general, I think it would be nice if administrators had the ability to reason about connectivity in their network. That is, who can talk to who in their network and how, as a result of plan changes, before the plan changes are actually implemented into the network. And this is what I mean by the ability to do what-if analysis on enterprise networks. And I think that the existing enterprises, basically you cannot do what-if analysis basically because of the decentralized nature of configuration specification in enterprise networks. If you look at enterprises today, you have complex configuration and policy information that's spread across a wide variety of devices and mechanisms such as firewalls, proxies, NATs, ACLs, VLANs, port security, what have you. And if you look at these mechanisms, they sort of operate at various layers of the network. The last two sort of operate layer 2 and below. The first two sort of at transport and application layers. The router cycles at layer 3 and so on. So given how distributed configuration is across various devices and across various layers, it becomes almost impossible to sort of reason about connectivity while accounting for cross-layer and cross-device interaction. And this is why I say, because of this distributedness, what-if analysis is fundamentally hard in today's networks. So I'm going to leave this issue here and move on to the second issue that I think is very interesting, and that is the ability to do effective troubleshooting. And what I mean here is actually two things. The first is the ability to view live exactly what is going on in my network at a particular point in time. Is everybody able to see this actually? No? Okay. I'm just going to speak out loud and hopefully you can understand. So, what I mean by this is, at any point in time, the administrator may want to understand, exactly who is talking to who, how many connections a particular group of users is issuing, what are the current levels of resource consumption, for example, how many HTTP connections are currently traversing my HTTP gateway, how many users are currently using my internet access link, and so on. And answering these questions is important to do things like capacity planning, availability tuning, avoid overload in your network, and also to do control plane troubleshooting. For example, if I see a particular flow that shouldn't exist, that tells me that something weird or wrong is going on in my network. The second sort of less intuitive issue that comes into troubleshooting is the ability to extract information about network events at arbitrary granularities. And what I mean by this is, again, by means of an example, it may be extremely nice if the administrator is able to say, how many connections did a particular single user or a particular group of users or maybe a particular group of machines issue to a specific other service or a group of services or a group of users. In other words, you want to be able to compose, the notion of flows, users, groups, and services in various ways to obtain information at your network, out of your network at various granularities. Of course, this also incorporates the ability to go back in time and ask the same questions about an arbitrary time window in the past. For example, between 10 and 11 a.m. yesterday, how many connections did people from the group sales issue to my HTTP gateway? And this is useful to dig out unexpected patterns of communication, to sort of compile protocol usage statistics, and also, for example, to look at problems in my network after they have happened. For example, to diagnose network access problems. Okay. Now, I'm very quickly going to say that existing tools and techniques have limited, if no support for this form of troubleshooting. In the interest of time, I'm not going to go into the details of what they do support today, but I'm going to argue that given the current design of enterprise networks, what existing tools do support is almost pretty much the best they can, given the current design of enterprise networks. I'm going to argue that the inability of these existing tools in supporting this form of troubleshooting arises from a specific facet of the design of enterprise networks, and this time the culprit is the distributed nature of decision making in enterprises. And let me sort of explain what I mean by this. If you look at how enterprise, how communication in IP-based networks typically works, the typical model is to allow everybody to talk to everybody else, and this is sort of based on the good old days of IP networks. And of course, enterprises don't want this. They want stricter controls over, exactly who can talk to who. And the way to exercise these controls is to place local restrictions whenever something is considered undesirable. And because, there could be different levels at which you may want to exercise these controls, you end up putting these filters or ACLs at layer 1 or layer 2 or maybe at the IP layer, or to achieve isolation at the application layer, you may put it into your firewall rules. So given the distributed nature of decision making about whether a flow is allowed or not, how exactly am I going to reason out what exactly is happening in my network at a particular point in time? Well, the only obvious solution to me is to poll at various network locations and obtain some amount of information or sniff traffic, collect it somewhere centrally, and do some kind of coarse-grained analysis. And that's the only amount of control that you can hope for given the distributed nature of decision making. And of course, if you wanted to obtain fine-grained information about the network and at the granularity of users, machines, etc., there's no support as far as I can see in existing techniques. So the third issue that I want to quickly touch upon is the ability to do fine-grained resource management. And the most obvious issue that comes to mind here is, whenever there is an overload or a failed link, I want the ability to quickly and dynamically route around the failure or the overload. But the less intuitive issue that also comes under the issue of resource management is the ability to achieve fine-grained control over resources in the network. Okay, what I mean by this is that it would be nice if the administrators are able to prioritize specific applications or groups of flows or users over others in the network. For example, an admin may want to say that I want to place a hard bound on the total amount of bandwidth that all users in sales group or all guest users in my network are able to consume. And this is what I mean by fine-grained resource control. And the third issue that I think falls under resource management, but it's less intuitive, is that of proxy and middle box integration. Now, if you look at how proxies are integrated into enterprises today, they enterprises tend to create a choke point in their design and throw middle boxes into these choke points so that the pertinent flows are touched upon by the pertinent middle boxes. Of course, this is bad because this creates single points of failure and it sort of severely restricts the design of enterprise networks. Ideally, however, what you would like to do is be able to place middle boxes at arbitrary diverse locations in your network, and more importantly, be able to say that I want to route different classes of flows differently through different middle boxes. For example, I may want to say that all traffic emerging out of sales is fundamentally not trustworthy, so I want to subject it to extra virus checks or do some extra compression, while Bill Gates is nice, so I just want to let him go, right? And I'm going to argue that there's almost limited or no support in existing tools and techniques in supporting these resource management tasks. If you look at existing tools, there are SNMP based tools which basically monitor various resources, and sort of if something sort of goes wrong, they flag something, they raise an alarm to allow manual intervention. OSPF has a bunch of knobs to do some kind of resource control, and you could do load balancing using DNS. But these techniques, either used independently or in together, do not give the kind of control over resources that I talked about on the previous slide. And I'm going to argue that the inability of these techniques to support this kind of fine-grained resource control arises from the lack of tight control over routing of individual flows in an enterprise. Okay? And what I mean by this is that if you look at enterprises today, the way routing works is you use forwarding tables and you use destination address based hop by hop forwarding to decide how to route your traffic. But the problem with this is that for each packet, you're using very little information about the packet to decide what to do with the packet. Right? As such, you end up losing control over individual flows or individual groups of flows that could potentially be of interest. Now, you could imagine adding additional information to your forwarding tables based on, say, source address based filters or source port based filters, but still, you run into sort of complexity issues. Your lookup could become slow, and as the size of your forwarding tables becomes large, you have to do some aggregation, and then you end up losing handles on individual flows or groups of flows. But the higher level bit here is that the ability to do fine-grained resource control in your network is tightly coupled with how well you are able to control the path of individual flows, and forwarding tables are basically the wrong abstraction to achieve this kind of control over individual flows in your network. Okay, so I talked about how am I doing on time? Okay, so I talked about these three issues: what if analysis, troubleshooting, and fine-grained resource management. There are a variety of others that are not effectively supported in enterprises today, and I sort of highlighted three issues that I think I sort of highlighted three causes that I think are fundamental to why existing tools cannot support these tasks. And what I want to do now is sort of abstract out certain design principles from these reasons and argue that if enterprise network design satisfied these principles, then all these network management tasks, along with other management tasks, could become vastly simple. And of course, over here I'm going to wear my clean slate hat, and there's almost no discussion of backwards compatibility. This sort of could require almost forklift upgrade of your networks, but I'm going to tell you what is a desirable, good, ideal point in the design space. So the first desired feature that I would like is centralization, and by this I mean two things. Centralization of specification of configuration, that is, you want a central list of, A can talk to B using HTTP, C can talk to D using AIM, but whenever he does that, his traffic has to go through a certain proxy, and so on. You want a central place that lays out the whole policy or the configuration for the network. The second aspect that I think is desirable is centralization of the decision making about flows. That is, if A wants to talk to B, should this flow be permitted or not? Now, if you think about the first centralization, it almost immediately makes what if analysis or analysis of connectivity almost trivial, because now you have a central database of all policies in your network, and all you have to do is just do an offline analysis of who can talk to who in your network. right? And the second centralization sort of makes troubleshooting and forensics simple, because whenever you have a central entity that decides whether or not to allow flows, what you essentially end up with is a full connection log. And you can imagine annotating connections in this connection log with information about sort of which user, which group, which service it's accessing, and then you can chug and mine this data to obtain interesting information at various granularities. The second feature that I think is desirable is the ability to somehow tightly control the routing of individual flows in your network. And what I mean by this is the ability to somehow centrally preordain the exact path that packets belonging to a particular flow should take in your network. May not be exact, it could be approximate. For example, you may just decide particular waypoints that that a flow should pass through. And I want to argue that this kind of a tight control over routing essentially sort of frees you from choke point based design. Because now you can take your middle boxes, place them anywhere in your network, and you can just simply compute routes that cause you to traverse the right middle boxes in your network. And also, once you have control over individual flows or individual groups of flows, you can do fine-grained resource allocation and resource management, because you can sort of play around with the routes that these flows can take. And obviously also this aids in troubleshooting and what if analysis, because the moment I know the exact path of the flow, I know exactly which resources in my network that particular flow touched. Ideally, I would have liked to cover this slide, which is basically putting all this together into an architecture. But it's okay that I leave it, because I think Martin talked about the architecture of ethane yesterday, where all policy is centralized and you sort of have control over routes by issuing source routes and circuits. But I do want to spend 1 minute, if possible, on talking about the effect of that kind of an architecture on network management. Now, notice that with centralization of policy and control over routing, your ability to do control plane related management becomes simple. That is, you can reason about individual connections, you can reason about whether specific upgrades violate policy, you can reason about routing specific groups of connections in a specific manner. But there's no obvious way how this might make data plane related management tasks easy, right? For example, what I mean by this is, there is no obvious way how I can support some bandwidth related restrictions in this setup. Right? For example, if I want to say I want to control the total amount of bandwidth that a specific group of uses, or I want to monitor the total amount of bandwidth that a particular amount of set of users is consuming on my network access link, there's no obvious way to support this. And the reason this is the case is because you've taken the decision making entity out of the data path and you put it separately someplace else, and your switches essentially are very dumb at this stage, because they simply just take a packet coming in on an input port and place it on an output port. But that's not the end of the story. You may imagine making these switches in this resulting architecture slightly less dumb, add some amount of management support, and the question then becomes, what is the minimal management support that these switches need to export to enable a wide variety of these data management tasks? For example, is it enough if they just do counters per flow? Would per flow queuing just do it for me? Would it be enough if they just sampled outgoing link utilization at various granularities and pushed it to the central controller, and so on? I'm going to end the talk here, but there are sort of a variety of issues here architecturally that I haven't really addressed. For example, what is a good policy language to express enterprise-wide policy, and how exactly would the central controller know the exact topology of the network, and so on. But I would be happy to take questions about that. Thanks. Yeah.
At some point you mentioned that forwarding table is the wrong abstraction to achieve some of these goals, and I guess you came to that conclusion based on the fact that you said today routing is based on destinations. But I'm not sure I understand that statement, because, well, you could do it on 5 tuples, just like Cisco's policy-based routing. You could do it based on anything. So I don't understand that statement that forwarding table is the wrong abstraction. Maybe you could.
Yeah, but I mean, you can do that, but ideally what you would want is control over higher level principles, right? You want to say flows emerging out of this user or this group of users, irrespective of the addresses or their network location, should be routed in this manner. And adding that level of abstraction into routing today is just impossible. You can imagine doing that. You can imagine doing specific matches on specific fields in the packet, that you could put metadata into your packets, but that just makes lookup much more complex and packet lookup slow.
So just to make sure I get it, so are you talking about, instead of doing stuff based on stuff which is in the packet, we need high-level identifiers?
Sure. Yeah, exactly. Okay, exactly.
So there's another issue, like the canonical forwarding table is destination based.
Sure.
But I guess what Hitesh is saying is that you could imagine forwarding on the basis of source, address, port, or some other information.
It's not a trivial statement to say, listen, that you do want to have control over the source, right? And it's not saying that there are today. It's just like the canonical notion of we're going to do forwarding is I've got an aggregated destination-based forwarding table.
I'm not sure how important the aggregation thing is in enterprise networks. So, so given that you're motivating all this research in terms of enterprise networks, I'm not sure how important that aggregation aspect is.
It's actually an interesting question. I mean, how much source routing is used today in operational networks?
I would say none, right?
So this is kind of the point, Nitesh, right?
No, but I mean, going back to the issue of aggregation, you're thinking about IP, right? But if you think about sort of layer 2 forwarding, it's fundamentally unaggregatable. And you could have if you think of a large enterprise, you could have many MAC addresses that you may have to fill your forwarding tables with. And that's, I mean, at some point you would hit some hurdle in terms of the amount of information you can put for each MAC address and use it for making decisions.